Hi, my name's Abby Pumper, and I'm currently studying a Bachelor of Clinical Exercise Physiology at the University of New England. I'm completing this presentation as a part of my assessment for Exercise 335 Motor Control and Human Development, coordinated by Dr. Dominic McNeil. The topic of my presentation is based upon a lab activity we completed in class on fatigue and performance. A major question you might have is why investigate this topic? Why is improving performance and fatigue so important to us? Well, I'll put this into context for you. The Australian sporting industry generates billions of dollars for the economy each year. According to the 2011-2012 statistics, Australia generated over $12.8 billion. Over 134,000 Australians were employed in the sporting industry, and over $8.2 billion was spent on sport per household. Additionally, in 2012, the average salary of an AFL athlete was over $300,000 a year, and 4 players in this year actually earned over $1 million. The sporting industry has a significant role in health and the social well-being of Australian individuals, plays a considerable role in the economic growth, and is strongly identified as part of Australian culture. You can see that sport is vital, and it generates a lot of money for individuals, companies, and improving performance variables such as fatigue improves competition, reduces risk of injury. So what is fatigue? Fatigue is defined as an enduring and subjective sensation of tiredness or exhaustion. It is a complex experience and incorporates both psychological and physiological factors, and is due to a lack of energy. There are 2 major types of fatigue. The first one being central fatigue, which is related to a boredom of a task and is associated with the central nervous system. The second type of fatigue is peripheral fatigue and refers to exhaustion of the muscles during physical activity. Fatigue can be associated with any type of exercise and be related to the individual's fitness. Research has seen that if individuals' fitness level is low, they are more likely to be associated with a quicker fatigue time. Fatigue during exercise is associated with an increased risk of injury, poor coordination, and less alertness to the environmental stimulus around them, and has been associated with a decrease in motivation, resulting in a poorer performance. The current research on fatigue is mixed. Some research has found that fatigue increases motor control performance, while others has found that it actually decreases motor control performance. Therefore, the aim of this study was to see the effects of physiological fatigue on performance of a motor skill. I hypothesized that fatigue would actually have a negative result on our performance of throwing the ball. The study design was a crossover involving 31 internal and external Exercise 335 students. Students varied in height, age, training experience, and physical fitness. Prior to the study began, students all gave consent, and the study was approved by the Ethics Committee of the University of New England. The physical fatiguing exercise was step-ups completed on a step board, and the motor skill task was throwing beanbags at a target on the ground 10 times. So the subjects were asked to pair up and asked if they would like to do the rest or the fatiguing state first. The step-ups were completed for 2 minutes and 10 seconds, while the resting partner counted their partner's steps. Then once the steps were completed, each partner had a go at throwing the beanbags at the target. Once this had been completed 10 times, both the individuals swapped from a resting to a fatiguing state. The outcome measures were the amount of steps each trial and the amount of times each individual hit the target with the beanbag. Once all the data was recorded and collected, it was transferred to Excel for statistical analysts. After calculating the mean, standard deviation, and completing t-tests, our results showed that fatigue did have an effect on throwing score. As you can see in this graph, individuals that were fatigued and then threw the beanbag performed slightly worse than individuals who simply rested and then threw the beanbags at the target. However, once the t-test was performed, there was found to be no significant difference between the fatigued or the rested individuals when performing the throwing motor skill. So our results found that there was no significant difference in the performance of motor skill when in a fatigued or rested state. However, we decided to further investigate our results and see if there was a difference in if completing the fatigue stepping task first or completing the resting stepping task first. This graph represents the individuals who were fatigued first in our protocol. The results discovered similar throwing scores between both fatigued and rested individuals. This graph represents the individuals who were rested first in our protocol. The results in this graph again demonstrate similar rested and fatigue throwing score. This shows that there is no significant difference between individuals who were fatigued first or individuals who were rested first, highlighting that order of the protocol made no difference to the results. Additionally, the results of the number of steps were found to be consistent across the 10 trials, ranging from 96 to 109, as you can see in this graph. So from the results I just showed you, you can actually see that there is no significant effect of throwing a ball, so this motor task skill that we performed, in a fatigued or rested state. So there was no difference in a fatigued state compared to a resting state performing this type of motor skill. Additionally, our results indicated that the protocol of going first in a fatigued state or first in a resting state had no effect on the score of the target throwing. So our results are actually similar to a bit of research that is out there. Hoger-Voss, who found that simple manual tasks such as tapping was not influenced by high intense exercise. In addition, Royal and his colleagues found that in elite water polo athletes, that the speed and accuracy of the goal shots were unchanged in a fatigued state. However, in comparison to our result, there is current research out there that is showing that fatigue does have an effect on exercise. So in comparison to the research I was just talking about, a study completed by Isaac and Pollan found that exercising at a heavy workload negatively affected motor control performance and that fatigue affected the complex cognitive motor skills tasks. Additionally, McNaughton found that fatiguing exercise at near anaerobic threshold decreased decision-making performance and decreased motor control performance. So it's clear from both of this research that it's mixed in this industry on fatigue and performance. So currently in the literature and our study, there was multiple limitations that need to be talked about. So our study was a crossover study completed in one day with a small sample size. This could have definitely affected the reliability and validity of the results. Additionally, the exercise experience of the individuals who were undertaking this study was not documented, and this again could have had a dramatic effect on our results. So as a fatiguing exercise of the step-ups may have actually not been of high enough intensity to elicit physiological or psychological fatigue. Fatigue was not measured in our study through heart rate or RPE, and therefore intensity of individuals' workouts may have been inconsistent. Individuals who are unfit or have a lower VO2 are actually more likely to fatigue at a quicker rate, and therefore the intensity of our protocol may have fatigued some individuals, but may not all of them. The results of the number of steps also indicated that individuals were able to stay at a consistent level of numbers of steps throughout the 10 trials, and that this kind of indicates to us that fatigue may have not occurred. Otherwise, we probably would have seen a drop in the number of steps towards the 8th, 9th, or 10th trial. So further research using a protocol which works individuals to the anaerobic threshold is required to enhance validity and reliability of current research, as well as documenting individuals' current fitness levels would also really help. Furthermore, the type and complexity of skill will also have an effect on our results. For example, our skill was actually quite simple in a very controlled environment. The results might be completely different if this task was taken out with multiple stimuluses. So therefore, research should look further into the different types of skills and the complexity of skills and the effects of the fatigue on these types of skills. From our results and the literature, we are able to communicate to coaches to say that fatigue might have an effect on their athletes' performance. You can say to coaches that sports and athletes who are involved in high intense environments and exercise and that are working close to anaerobic threshold are more likely to fatigue, therefore more likely to reduce performance and result in poorer competition. Additionally, you can talk to coaches about increasing the athletes' fitness levels to prevent this fatiguing occurring so quickly, and talk about interchanging athletes when they do become fatigued to reduce the risk of the athlete's injury, but also to improve motor skill performance. So from this investigation, it's clear that research on fatigue and performance of a motor skill is inconclusive. It is known that fatigue is affected by a number of variables, such as individuals' athletic ability, the motor task type, and the complexity of the skill. Therefore, further research into these variables should be looked into, as well as increasing sample size and conducting studies of randomized controlled and blinded studies will help develop our understanding of the effects of fatigue and motor control on performance. Thank you so much.